Hi, my name's Chris Gage. I'm Director at Turner Townsend. I'm going to talk to you a bit today about infrastructure and construction, about how Turner Townsend use Tableau for research and thought leadership, decision support, predictive analytics, geospatial analysis, and even recruitment. I'm hoping that what you'll take away today is a greater appreciation of the industry, some ideas for different ways to use Tableau, and some useful links and tools and tips throughout the way. So, move on to a bit about the company. So, we are a leading global program management and construction consultancy that support organisations that invest in, own and operate assets. We talk about physical assets, so the three key sectors we work in are property, infrastructure and natural resources. You can see from the map there that we're involved in work across the globe and actually have day-to-day operations in many places. So before we move on, I'm just going to talk a bit about my own role at the company. So I'm a consultant in the infrastructure sector. I founded our commercial analytics team about 3 years ago. We support a range of services from commercial and forensic investigations to building management information to help organisations run their major programs. So there's going to be a bit of infrastructure focus in this presentation. So before we get started, what is infrastructure? So The Economist has a pretty good description. And they describe it as the economic arteries and veins. So we talk about roads, ports, railways, airports, power lines, pipes and wires that enable people, goods, commodities, water, energy and information to move about efficiently. So it's pretty fundamental, I think, to our way of life, and I would even go as far as to say that infrastructure is civilization. So what are the data features of infrastructure? So there's huge value in being able to predict the outcome of projects. So predictability is one of the biggest challenges facing our industry. It's got a big impact on things like investment. So the attractiveness of infrastructure as an asset is determined in part by a level of risk, and risk is driven by how predictable it can be about sort of outturn cost and time to deliver. There's a lot of talk at the moment about how we get private sector more engaged in investing in infrastructure. So it's pretty key. Infrastructure, by definition, has a location, so it's physical assets. So from a Tableau perspective, certainly the geospatial aspect is really important for us, really useful. The next one there, time is as important as money. So we're not just, in terms of measures, we're not just looking at costs, we're looking at money, we're looking at time. In fact, a whole range of other measures, so things like quantities, meter cubes, or kilometres, there's all sorts of measures involved. So we need a tool that can handle all those effectively. I mentioned infrastructure being, location being key. Also, physical attributes of physical assets need to be captured electronically. There's a big movement at the moment called BIM, which is Buildings Information Management, and this is really the future. And what we're trying to do now is capture electronically assets as they are built, so that you can replicate entirely the physical world and the digital world. Large amounts of money are involved, so we need a tool that can handle large amounts of money and therefore data. We'll come on to some examples of that in a moment. There's also macroeconomic factors involved as well. So when you're trying to compare different projects across different countries, it's not always as simple as just currency conversions. There's different weightings in the way that countries are able to sort of purchase things like labour and plant materials. So they're the kind of data features, and that kind of drives our approach in using Tableau. And so just to kind of bring to life a little bit the infrastructure industry, I'm going to share the first workbook, which is an infographic of 3 major programs happening right here in London. So I'll just move over right now. Okay, so the first of the major programs is the Northern Line extension. So this is an underground link from Kennington at the end, currently at the end of the Northern Line, to Battersea Power Station. Battersea Power Station there being pictured in the image there, and it's a project that Turner Townsend are actually working on. We're project managing the initial phases of that project. It's a real marquee project for us to get involved in. The project will involve 2 new stations at Nine Elms and Battersea, and a huge amount of redevelopment at both, including the new Covent Garden Market and also proposed US Embassy. So key kind of metric there, up to 25,000 jobs and 16,000 new homes could be created as a result of this project. Now this graphic also shows when the project's going to happen. So it's due to start in 2015. It will run 5 years till 2020. The total construction cost is £1 billion. It's a significant amount of money. Now, the graphic on the right, a key theme running through all 3 of these projects is tunnelling. So there's not much space in London to build things above ground. So what we tend to do is go underground. And we can see here, this graphic is really just trying to show visual perception of how deep these tunnels are and how big they are as well. So we can see a small image of a human being there, about 2 meters tall. We've got a tree, which is, we can say, 5 meters. And it kind of helps you visualize exactly how deep these tunnels are. So I think it gives an indication of just how deep the Northern Line extension will be, just over 30 meters below ground. It's also about 5.2 meters in diameter. Okay, so that's the Northern Line extension. About 10 times away. So following the great stink of 1858, which is basically 150 years ago, we had raw sewage flowing straight into the River Thames, and it got so bad that in 1858 they actually had to close down the House of Commons and relocate to Oxford, and it was called Great Stink. And a gentleman called Sir Joseph Bazalgette then went about building London's sewage network, and he did that in the 1860s, and it's still there today. Now, at the time, we had a population of about 2 million people in London, but it's quite a prudent chap, and he built enough capacity for that population to double to 4 million. However, today, we're now in a situation where we've now got 8 million people. So we're now going back to the stage where we've got raw sewage washing straight back into the River Thames. And you can see in the picture there, key stat there is 55 million tonnes of raw sewage washed into the Thames last year. So it's a problem that definitely needs to be fixed. Now, there's a range of different ways you can do that. You could rebuild the whole thing from scratch. That cost you about 50 to 60 billion, which buys you a high-speed 2 link up to north of England, plus a bit of change. But they came up with a much more cost-effective way, which was to just create a tunnel that tracked underneath the Thames and enabled the excess kind of storm water to be washed out. And it ultimately ends up in Bexon sewage treatment works and reduced the city. Still a significant cost though, £4 billion. So it's a major project. And the tunnel graphic on the right, we can see the deepest tunnel in London. This is going to be nearly 70 metres below ground, and also a very large tunnel, 7.2 metres diameter. We can see that project's going to be starting next year, and that will run 7 years to 2022. So the final one is Crossrail. This is kind of saving the best till last. So this is Europe's largest construction project. It's going to increase London's rail capacity by 10% It's 100 kilometres in length. 42 kilometres of that is tunnelling. There's going to be 40 stations, including 10 brand new stations. Going to bring 1.5 million people within 45 minutes of me to London. That's been talked about for a very long time. First conceived back in 1880. Just to give a bit of an indication of how long these things take to actually come about. In fact, the name Crossrail was coined in the 70s. There was also, it got quite close to being started in the 90s, but these were the days before Keynesian fiscal stimulus. So unfortunately, the recession hit and the project was put on the back burner. However, it was resurrected, and on the 15th of May 2009, first broke ground at Canary Wharf, and the project was started. So you can see from the timeline, this is well into this project now. In fact, we're about 80% through tunneling, so we're making good progress, and due to finish in 2018. Picture here is a kind of boring machine. These are named after, quite oddly, things like we've got two tunnel boring machines called Phyllis and Ada, and they've recently completed their journeys, 6 kilometres, connecting Royal Oak to Farringdon. But I guess the scale of this one is apparently 15 billion, just under 15 billion pounds of construction cost there. So this is a huge project. It's very significant. And just to bring that into context, that's the GDP of Jamaica. In terms of tunnel depth, it's pretty deep and also quite wide. You can see there just under 50 metres. Okay, so what I wanted to show there was really how you can use Tableau to create infographics and really convey interesting messages to other people. So we'll now switch back to the presentation. So just quickly, we're now going to move on to how we use Tableau at Turner Townsend. So just a couple of quick stats here. We've been using Tableau for 18 months now. I think there's about 12 users now in the UK. We've analysed a significant amount of information to the tune of about £60 billion worth of cost data associated with it. So it's significant amounts of analysis being carried out. So we're now going to move on to different kind of applications for the tool. So first one is research and thought leadership. So as a consultancy, we come into contact with huge amounts of knowledge and data, and we can actually help the industry improve best practice by pulling all that information together and drawing out key insights, and then playing that back through lots of articles and thought pieces. So I wanted to give you an example of how we've actually used Tableau to enhance that. So we recently authored an article for a magazine called Building. I'll just take you through that now. So Building is one of the key journals out there in the industry. And this article was about how you can compare infrastructure projects across different countries. And it can get quite complicated because it's not just a case of to really get full insight. It's not necessarily just a case of converting currencies. And there's one measure that economists use called purchasing power parity. I won't go too much into the detail now, but if we come to the bottom of this article, we can see the unmistakable side of the Tableau geographical map. Now, purchasing power parity is a bit like you may have heard the Big Mac index. So if you bought a Big Mac in this country, I don't know how much it cost, maybe £2. If you went over to another country and the exchange rate was $2 to the pound, you might think that it would cost you £4 to buy a Big Mac in that country. However, it's not always the case, and it depends on the local conditions and how much it costs to employ staff to run the restaurant and various other factors like that. Now, we've pulled together purchasing power parity for the construction industry, which involves putting together a basket of goods and benchmarking on that basis. And that's really what this graphic is showing. So the focus of this article is really on airports. So it's about as simple as Tableau can get in terms of interactivity. So we've got two options here, both airports. We've got domestic terminals and low-cost carriers. So domestic terminals are going to be like your sort of Heathrow Airport, so your Gatwick, and then the low-cost carriers being Stansted or Bristol Airport. And then you've got options between looking at purchasing power parity or just a straight conversion to US dollars. So we can see if we change the drop-down box, not a huge amount of change between different countries. It's worth saying that green indicates the low cost, and this by the way is the cost per metre squared of building an airport. So it ranges from the low of 2,280 up to $5,785 per square metre. So we can see, for example, Russia's quite expensive compared to, say, Canada. So it doesn't vary hugely when you switch between different airports in terms of relative costs between countries, although the actual costs do vary. But when we change from purchasing power parity to US dollars, you can see some quite significant changes. So Canada further becomes the most expensive if you just use a straight US dollar conversion. So it's really about kind of normalizing local factors and using purchasing power parity to give a more accurate view of how much these things cost. So that's embedded within the article. So it's a great example, I think, of how you can use Tableau to bring a story alive and make it interactive and make it more interesting. Now, this article is really generated off the back of a study that Turner Townsend carried out. I'll just quickly run to this PDF here. This is the document here. So it's 62 pages long. Nice glossy, really good looking document. Very interesting analysis there, created by a gentleman called Gary Emmett, one of our economists out in Australia. When we get down to about page 12, you can see page 12 onwards, we've got lots of tables. The majority of this document is tables. Now, this is fantastic report, but I decided to try and create something in Tableau that would simplify this from 62 pages into just a few. In fact, let us come to it. We managed to take it down to 4 pages. I'll just explain how this works. So this is uploaded to the server. So our first page here is really looking at various countries. So we can sort of hover over these and just explore, get a high-level view. So I might say the World Cup's on at the moment, so I'm interested in Brazil. Public spending and maintain growth well beyond the World Cup and Olympics. So we see how that's true. So let's click on it, find out a bit more. And so you get the headline, but then you also get some of the underlying detail below it. Now, we can also now see some icons have appeared. We've got airports. If we click on airports, now we can see that table is being included in the analysis. And we can also click on car park. We can click on commercial property, click on materials. So rather than having a long list of tables, we've actually now got an interactive graphic, and you only see what you want to see. So I think it's an excellent example of how you can use Tableau to just really take all that detail, hide it behind the scenes, and just focus on the bits that you're interested in. If we go through to the other pages, this was really where the graphic for the article came from, but now we've got airports, we've got everything else as well. And this is really just allowing you to compare geographically various types of costs that are out there. We can look at hotels, for example. We can filter down by 5-star luxury and see how much it costs and this is all purchasing power parity. We've also got some bar charts looking at market indicators. These are things that indicate how hot the market is. You can see South Africa competitive tenders at the top of the list there. We can look at contractors' margin. The people out there actually building stuff, how much money are they making in terms of margin? We can see in India it's highest and then it's lowest in some of the more developed countries at the bottom there. We can also switch between a bar chart and also geographical view. And then finally, the last page is just really a matrix, just bring all that together and showing which countries are currently cold, lukewarm, or warm in terms of their economic activity, and then the outlook going forward. How's that going to change in the future? And we can see that some countries are in overdrive and they're going to continue growing, getting hotter. We've got Brazil here, we've got Russia here, although this is before the recent troubles in Ukraine, and we've also got some other countries. So I think that's quite an interesting example of how you can consolidate quite a long report into something interactive and visual. Okay, let's switch back to the presentation. And by the way, I've got a link in there, so if you've got Google Googles or a similar application, if you want to have a look at that article, just scan that page and you can get a link directly to it. The next one I was going to come on to was some analysis I did of the rail industry in the UK. So if I just switch to that now. Now this is using open data that's provided by the Office of Rail Regulation. And I think this is a really great development of recent years that now companies, particularly public sector, are starting to publish more and more data, make that available to general public to analyse. So this information, what this is showing is across the UK or across England and Scotland, the number of passenger journeys that are being undertaken. We've got data from 1997 to 2013, so 15 years worth. Now, each of these bubbles represents an individual station. If we hover over, we can see what the year was, how many entries and exits, basically passenger numbers, and the change on the previous year. Now, this is the first year, so obviously no change. And what we can do, and we've also got, you'll see this in a moment, where you've got a growth on the previous year, you've got green bubbles, and where you've got a decline, you've got red bubbles. So it's quite interesting to run the sequence now. We just click play on this, and we can see it cycling through each of those 15 years. So we see quite a lot of greens, see kind of periods of green and periods of red. It's just interesting to try and understand what those correlations are. So if we wind it back again, we can see early 2000s, it's pretty strong, although in 2000, 2001 we start getting more reds, and there's a bit of a downturn at that time. Then it kind of builds up to late 2000s, and as we know, the economy is growing really well at this point. So you can see lots of greens. Then the financial crisis hit, and we can see 2008-9, a lot more reds, and then it picks up again. So the correlation there would be that station usage is correlated with economic activity, and we can imagine that maybe when times are tough, there's less travel, maybe for business users in particular. But when everyone's trying to tighten purse strings, then they travel less. Now we can also look at, got some other graphics here, so we can look at how the split is over time. So for example, and this is really interesting, I think. So if we look at total passenger journeys, there's quite a clear, almost 50-50 split between London in the dark blue, and the rest of the UK in the light blue. And we see that pretty much vibrates around 50% throughout the whole period. There's no kind of directional change during that period. It seems to fluctuate around an average. Whereas if we look at the total passenger numbers, we can see a steady increase throughout the period, going from 1.2 2 billion passengers up to 2.5 billion passengers in 2012-13, so doubling the passengers over that 15-year period, which is amazing, really. We've also got in here every single station, so you can look up your own station here. My one is Basingstoke, which is coming every day. We click on that. We can see passenger numbers have increased from 2.8 to 5.2. Again, kind of reflects the overall trend is almost doubling. And I've been doing that for a journey for about 3 years now, and I can certainly confirm that it's certainly gotten no less busy on the trains during that period. Okay, so the next one is just showing how it's really a league table, I guess, of the different stations and where they sit. So you can see all of the orange is London. We can see Glasgow is the top one there from Scotland. Got Manchester, the next highest regional one. This is 1997 to 98. So we see London Bridge was the largest station at that time. We fast forward through to 2012-13. You can see now London Bridge is down to 4th place, and Waterloo now by far the biggest station, 95.9 million passengers a year. It's phenomenal. I wonder how long that'll be before it hits 100 million. We can filter here. So if you're living in North West, we can click on there. You can see all the West ones, so Manchester, Piccadilly, closely followed by Liverpool. Probably expected. You can look at any of the regions you want to. Finally, there's just a bubble chart on the different infrastructure providers, also coloured by the region. So you can see Network Rail. Network Rail own all of the track, whereas recent times the train operating companies have taken on the ownership of the actual stations. So you can look at the bubbles and see how much those passenger numbers relate to each of the train operating companies. Okay, so back to the presentation. If you want to get the link to that, just follow the QR code, and you can play around with that if of interest. Now, the next one is really kind of picking up on some of those themes and really trying to explore it to the next level. So what I was trying to do here is I saw that London obviously provided almost half of all of the passenger numbers travelling on in England and Scotland. So just trying to understand who actually funds the railways. And I guess the hypothesis is perhaps commuters to London fund the nation's railway. I know from my experience that it's very expensive to commute to London. There's lots of very busy trains. When I've travelled elsewhere, the trains are a lot less busy. I just thought it was interesting to dive into this a bit further. So what this is another infographic. And what we can see here is map the UK. We've got a pie chart here, which probably goes a little bit against the grain, Tableau. Not too keen on pie charts generally, but I'm a bit of a fan, and I've actually had to do a bit of a workaround to create this donut chart. So I had to create a pie chart and then put a white circle in the middle just so we can put the percentage in. Now what this percentage is showing is the percentage of passenger income as a proportion of the total funding of the railway. So across the whole of England, Wales and Scotland, it costs £12.3 billion to run the railways. 63% of that is provided by passenger fares. But of course that varies depending on which route you're looking at. So if we click on Scotland, that number falls down to 33%. It's just a third of income required to maintain the railway in Scotland comes from passengers. Wales is also quite low, 38%. If we look at my own route, all the way up to 86%, and Sussex is quite high at 75% as well. So there's definitely a disparity between how the different operating routes are funded. Now, I've also got this bar chart here, and the colours transfer over to this chart. So this chart is a representation of these colours, and we've got various parameters that we can select. So this one is the amount of funding per passenger journey that the government provides. So if you look at this, Wales, every journey, every passenger journey on average attracts £9.33 of government funding, all the way down to Wessex, where it's just 11 pence. So you can see there's a lot more government funding going into some of these regions here compared to the regions at the bottom of this chart. What about train density? So I know I struggle to get a seat many days, and that's reflected here. So at the top of the bar chart here, Wessex, average of 141.5 passengers per train, whereas Wales is less than half of that. So much more open trains there. And it's basically the opposite of the government funding. That's interesting. Now the third one is showing how much an individual pays per kilometre on the routes. Actually, the interesting thing here is that it's pretty similar, except for Scotland, which is a little bit lower than the others. You know, they're all within 3 pence of each other. So really, if you triangulate those three parameters that we've seen there, the conclusion I draw from that is that yes, London commuters generally fund the nation's railway. However, it's not due to me spending more per kilometre journey. It's really about more busy trains. And actually, if I think about how I feel, I find that much more acceptable than having to pay extra myself. You know, just have to go to work on a busy train, which is less an issue. So anyway, that was an interesting way of really getting to the bottom of an issue and understanding through visualization and graphics, how the rail network is funded. Again, I've got a link there to have played that. So you may have been interested in how I created these polygons here. I just wanted to demonstrate a tool now that I've actually developed to easily create these things. Now, normally, if you've got, Tableau provides its own maps of countries. The key here is that you're splitting a country down into different components that don't necessarily match what you'd normally be able to get shape files or other coordinates for. So really, this tool is all about being able to create your own coordinates from any image, really. So it could be a country, it could be literally anything you want. So it's an Excel spreadsheet, so you don't need any specialist software. Just need this spreadsheet, and behind it we've got this sheet here that creates coordinates, and it's literally just a VBA program, and it records coordinates that you select as you go through. So what I'm doing is just tracing around the edges of Scotland here. Obviously, the more points you put in, the more accurate result you'll get, but we'll just do a very crude image of Scotland. So this has created all the information we need now to create a shape in Tableau. I've linked this to a Tableau file, so if I just go back and save that, now if I refresh here, we should be able to see an image of Scotland. There it is. So very quickly, we managed to create a polygon there of Scotland, and we can actually go back now. And if we change, so this area here is London North East. So all we have to do is change that to LOV. And we'll just trace around this as well. Again, just very crude, just to demonstrate the example. All the way down to London, and up through the Midlands, and then back again. So save that. Refresh. There we have it, another polygon. and these are differentially flexible. Set different colours for these as well. But ultimately, you can do any of the normal stuff that you normally do in Tableau, so you can link these colours to, costs or populations or anything else you wanted to do. So it's really nice little tool to build that up. If you spend a bit more time on it, you can build up a nice diagram like that. And actually, sometimes when things aren't precise and they're a bit kind of stylized, they look better. What I've tried to do here is get something that's a bit more design-led than just purely data-led. Okay, so, and again, if you want to link to that spreadsheet, you just select the QR code and you'll be able to get that. So that was kind of thought leadership research. Now I'm going to move on to decision support. This is probably the most classic use of Tableau. So it's drawing simple insights from complex data to enable decisions to be made more easily. The real benefit I find with Tableau is that it enables you to visualize information really easily, just pull out all of the key items that you need. And the other benefit that we find is that you can get up and running very quickly. You can put it onto a server and get it on your iPad. So it's great working with clients and help them get insights really rapidly and easily to consume. So the example I've got here, this isn't infrastructure actually. This is some work we did for a global bank. The name of which, just for client confidentiality reasons, I've had to hide there. Now, what this graphic is showing is a tool really. So if we just kind of shut off all these parameters. So this bank's got branches, properties all over the world, as you can see here. Kind of UK based, you can see a real kind of concentration of properties there. Now, in terms of that's a lot of properties to maintain, and the question is how do you manage that? How do you track the most important properties to spend limited funds on? So what was done was to go and survey all those properties and work out how important they were to the overall portfolio, and then how well those assets were performing. And really, we can then use those parameters to direct how where we spend the money on improving those assets. So if we take importance to 3, so everything that's more important than 2, and then everything that's performing worse than 3. And we can see there's a few crosses that you can see on the graph there, on the geographical image. We've also seen this scatter chart. It draws out those key areas that we need to focus on. Now here I've taken out a lot of information from tooltips, but you can get addresses, you can get all sorts of information. But really what this does, it focuses you on those properties that are most important to spending money on. And to achieve that, we've also got a calculation here that works out how much you need to spend. So in this case, it's £600 million to improve those properties. Now, what we could say is we want every single property in our portfolio to be at least performance of 2. So we could exclude all of the importance measures and literally take a slice across everything that's underperforming significantly. And there we can see a much larger cross-section. We're looking at nearly £4 billion of investment there. So it's a very, very useful way of visualising exactly where you need to focus your effort. And there's many examples of that. I mean, I guess most uses of Tableau tend to be around dashboards and providing information. But I've tried to focus a lot of the examples on areas where we're doing something a bit out of the ordinary. So the next one is geospatial analysis. So as I mentioned before, in the built environment, everything has a physical location, and it can also play a really important role in the value of assets and being able to understand those assets. So we did a lot of work around this. I'm just going to show you one example here. And this is actually the first workbook I ever created in Tableau. And we included this in the business case. And it was something I was able to create very quickly, really. And just to show you exactly what this enabled us to do. So again, this is using things for client information which we've anonymized. So we've created this kind of bogus company. But it was a utility company. It's based in Eastern England. Now, what this is showing is fuel expenditure. Okay, and we can select diesel, petrol, etc. But it shows you where fuel was purchased around the country. We've got some other information here around sort of prices and also weekly spend. But I guess the key thing for us is where this money was being spent and what sort of prices were being obtained. And it's interesting that you've got people buying petrol outside of the region, right? Even in places like Scotland. So what we're able to do is we can select visually all of those areas where fuel is being purchased, and we can create a set. We can call this outside area. We'll come back to that in a second. We can also look at usage per driver. So all of these represent an individual, and it's aggregated all of the fuel expenditure per person. Okay, so we can observe those if we've had to take out names. But here we might look at, these are the scatter showing price along the bottom and volume up the y-axis. So here we're focusing on the areas where fuel's been purchased most expensively. We'll probably just take out some of the really low value items in terms of low volume items. Now we can select these, and we can say that these are the greatest set and call them expenses. Now, if we go back to that original set that we created, we can pull that outside area into filters, and we can see each of those individuals and how they play out. We can actually go and speak to those individuals and understand, you know, why that money has been spent outside of the relevant region. Going back to the main page, we can also go into that sheet, and now we can bring in the expensive items and bring those into the filter. So here we can see where that money has been spent on the most expensive items. Now, before we go into that further, let's just go to the final sheet. And this is about the fuel suppliers. So we can also analyse costs by supplier. And again, we've got pricing at the bottom, volume up the y-axis, and we can see that most money is being spent at Tesco and BP. BP is the most expensive. So what we could propose an argument is that if you switch from BP to Tesco, then if that's 142 pence per litre, you could reduce that to 138 pence per litre, 4 pence per litre difference. And if you did that for 64,000 litres, there'd be a saving. And yeah, it may not be a huge saving in this particular example, but this is just one quarter's analysis. It's been able to kind of real evidence-based ways of reducing costs and improving efficiency. So one challenge that you might get back is, well, actually, we can only use BP station because that's the only one local to us. So what we can then do is, instead of having the price per litre is the red to green, we can actually bring the supplier into colour. We can also filter by supplier. If we just for simplicity, we just take BP and let's go. So now we can see that actually in some of these cases we've got BP fuel being purchased where there is also Tesco fuel being purchased, and so we could then present more of a challenge as to whether they could move their supply from BP to Tesco. So anyway, that that I think is a very interesting way of kind of carrying out audit analysis, but doing it in a visual way rather than using the previous techniques that we used to use, which was more kind of Excel or audit software kind of approach, where you're not viewing things visually, you're looking at cells in a database or a spreadsheet. So that was a massive benefit for us. Now, in terms of this link here doesn't link to this particular graphic, but what it does do is link to an interesting function in Excel. So if you want to geocode, I found this great link, which I'd definitely recommend. If you just go back to this for argument's sake, if I was to type in the query, London Bridge, London, if we type in Google geocode, it returns latitude and longitude coordinates for that. Now, to understand how that works, all I'd recommend is that you just go and follow that link and find it. But it's a great tool for geocoding a whole range of data. You can have a spreadsheet with, I think the limit's up to 7,000 on a free basis. But use the Google API and using VBA to basically convert a search address that you might put into Google and return to that long. It's a great little tool there to help geocode data points. So that's all I found geocoding. Now I just wanted to do a quick example of where we've used predictive analytics. So as I mentioned before, predictability is really one of the key challenges to the industry in driving value from infrastructure. And the example I'm showing you now is it's just a model which predicts the cost of installing lifts. So we've got many of these other models being developed, but this is quite a nice, simple one, just to demonstrate. I've redacted the numbers, but hopefully you'll be able to just see that those numbers are moving without necessarily seeing the exact amount as I change these. Okay, so it's very simple. We've got a graphic here, and you can select from multiple parameters. Now, all of these parameters have an impact on cost. So whether it's the finish of the lift, whether it's scenic, disabled, the capacity, number of people you can fit in that lift, these are obviously all things that have an impact on cost. And whereas in the past maybe we simply averaged out all of these factors to get an average cost, what we've now done is to basically look at all of this data and do multiple regression to work out the impact of each factor on the cost of installing a lift. And that means that if we've got a combination of parameters that we've never seen before, we can still predict an outturn cost. So it's very much in the predictive field. It's a great tool for being able to get a bit more predictability around costs. And it's not just lift costs, it's you can apply the same techniques to everything. And the other thing is you can then provide this over the server, and we can have clients with portfolios of different cost calculators that are relevant to their particular program of works, and it just helps them develop rough cost estimates for projects. So that was a brief look at predictive cost modelling. Final one I really wanted to talk about was actually how we've used Tableau in our recruitment process, and this is just something I've tried in my own team. And the reason is because in my team, analytical presentation and storytelling skills are extremely important due to the nature of work we do. And Tableau is so quick and easy to get started that it's a great test actually for testing aptitude using these sorts of tools. So what we did was we came up with a test for people to performing their interviews. So it's maybe a bit of a challenge, but the challenge was to, first of all, download Tableau Public for free, obviously, learn to use it, upload data, open data from Transport for London, which we provided, find something interesting to talk about, and then give a 30-minute presentation at the interview. We only gave them 2 days to do it as well. So, you know, outside of the day job, so it was a big challenge, but that's what it was all about, really. And I just wanted to show you some of the results. So I'll just quickly go to that workbook. So, I mean, you've got to bear in mind that this has been produced by a couple of graduates who have literally only been using the tool for 2 days, a matter of hours. So it may not be the slickest Tableau you've ever seen, but I was pretty impressed by some of the outputs we got here. So this is showing Transport for London, the overall number of journeys. So a bit like the graphic we showed earlier, but rather than being for heavy rail, this is bus journeys, underground journeys, DLR, overground, and tramlink. And straight away, the interesting thing I found here was actually bus journeys more than double London Underground journeys. And I guess the reason for that is just the scale of the bus routes around London. We also looked at DLR journeys to overground. So you can see here that tramlink only starts from about 2002-03, and also the overground's fairly new as well. We can see that all of these are increasing. There's not really any, as these new forms of transport come online, it really doesn't dent the other forms of transport. So it just shows how much demand there is in the system. This next one is just showing the correlation between fares and number of journeys. So what we can see here is what you might expect, that as bus fares increased, there's quite a strong correlation, R² of 0.6, to the number of journeys, so people moving to other forms of transport. As for underground, that wasn't the case. So the number of journeys increased despite increasing fares. So that indicates that there's more inelastic demand in underground than there is for buses. I guess that probably makes sense, because with buses you can travel by car, whereas with underground it's a little more difficult to do that. And again, strong correlation there and strong significance. And this is really just a chart bringing them both together. Now, there's two final dashboards, and this was chap called John Coughlin actually produced this one, and he looked at bus fares for the rest of the UK versus London, and just look at correlation there between real measuring costs and bus fares, both in London and the UK. What we can see here is quite a different picture. So as motoring costs go up, we can see that in London, bus fares have also gone up, but in the rest of the UK, bus fares have gone down. And it's a slightly different story for for rail fares. So underground fares have gone down in line with motoring costs, but rail fares have gone down. So anyway, I think I can bring the presentation to an end there. That was just a really, really interesting example, I thought, of just how far you can get with Tableau, the minimal kind of experience using the tool. And I think that's probably the biggest thing about Tableau that differentiates it from the cloud. So just to round up then, we talked about the world of infrastructure and construction. Hopefully you've learned a bit there. Heard about how Townsend use Tableau, and a few links, tips and tricks there for using Tableau in slightly more ways, and also some tools to help you build your Tableau analysis more effectively. So I've included my details there. If you've got any questions, please don't hesitate to get in touch. Thank you very much for listening.